The factored numbers like 24? 24. You guys did like a factor tree thing. It looks like this.
What?
You guys ever do factor tree? Okay. Now, it's still the same idea. You're factoring. But with the polynomial functions or expressions, you're not going to write it like this with a tree. You would do something more like this. You go, okay, 24 is right here. What's the number that divides 24? And you're like, oh, well, 2 divides 24. So you go 2, and then 2 times what? 12, right? All right, 2 times 12 gives you 24. So here's 2 factors that multiply to give you 24. But I can still factor. What is another number that I could divide 12 by? I can't divide 2 by anything else to change it. What can I divide 12 by? 4, 3, 2, or 6, right? And so if I divided it by 6, I would write 6 times 2. And you can keep going. I mean, 2 is prime, 2 is prime. This is not prime. I can divide 6 by 2 or 3. And so I would write it out like this. 6 divided by 2 is 3. And then I have that 2 chilling out there. And you guys know a more efficient way to write this answer. You would write 2 raised to the 3rd power times 3. Well, we're doing the same thing for this function. There's no fancy way. There's no trick like grouping or anything like that I can use on this to factor it. But what you can do one of 3 different ways to factor it. I'm going to do the way I like the most, okay? But I'll tell you the other way really quick. One way you can do this is you can multiply these 2 numbers together, x plus 2 and x minus 1, and then whatever your result is, you can divide this polynomial by that result. That is one way to do it. I ain't going to do it that way because I like synthetic division way more. Okay, so like if I wanted to synthetically divide this by x plus 2, what would be the 0 for x plus 2? Negative 2. So I'm going to put negative 2 right there, and then I have 2, 1, negative 5, and 2. Okay, I got 2, 1, negative 5, and 2 for my polynomial function. And then I bring down the 2. Then I multiply 2 by negative 2, and I get negative 4. Negative 4 plus 1 is going to be negative 3. And then negative 3 times negative 2 is positive 6. I add those 2 together. I get 1. 1 times negative 2 is going to be negative 2, and I get 0. Boom. Which I expect. I expect to get a 0 because this problem says this is a factor of this. But I don't want to just divide this polynomial function by x plus 2. I want to also divide it by x minus 1. So let's write out what we got. We have 1, negative 3x, and 2x squared. That would be multiplying times what I just took out, x plus 2. Do you guys remember with the 24 how we would write it out? We just divided by x plus 2. So I'm putting that right there. I'm putting my result right there. Now I'm going to divide this by x minus 1. What is the 0 for x minus 1? Now. And so I'm going to write now. And now I'm going to write 2, negative 3, and 1 from that one. And I'm going to bring down the 2 and get busy. So there's a 2. 2 times 1 is 2. 2 plus negative 3 is negative 1. Negative 1 times 1 is negative 1. Negative 1 plus 1 is 0. So what am I left with? I'm left with negative 1 and 2x. That is the factor that I would get after I divide this guy by x minus 1. And so if I were to write this in factored form, this is what it would look like. There's all my factors. I have these 2 factors down there. What are my zeros for these guys? X equals... We have 1. We have negative 2. That's right. That's what we got for these guys, these first 2. What is the 0 for that one? Yeah. We get 1/2. And if you didn't see that, you can take 2x minus 1, set that equal to 0, and solve it. So there you have it. There's your zeros. There's your factors.